দেখাচ্ছে, এটা তো 250
So,
দেখাচ্ছে না।
a confirmation about the audio, please. The audio
হ্যাঁ,
is
মাই জিও
clear?
পে গেছি তো।
Good. This particular is really relevant
হ্যাঁ,
both for your prelims as well as mains examination. So, in the prelims,
কিন্তু ওগুলো
you do
দেখাচ্ছে,
get
কিন্তু ওই যে
questions,
ট্রু
very
5G নাই
frequent
তো।
questions from this area. So, there you will have a general
না না,
aspect
টাওয়ারের
of
ডিস্টার্ব
the
বলে না।
concept. So,
এবার ব্যাপারটা হচ্ছে যে আমি যখন ওই যে
factors
আমার যে
influencing Indian
জিওর অ্যাকাউন্ট আছে,
climate,
জিওর অ্যাকাউন্টে সব নাম্বার দিয়ে লগ ইন করছে, অন্যান্য সবগুলো সব কটাই ট্রু 5G দেখাচ্ছে, কিন্তু এই
influencing
নাম্বারটা মানে ওই যে সেদিনকার নাম্বারটা কিন্তু ট্রু 5G দেখাচ্ছে না। নাকি ওই সিমটা আবার প্রিপেড 4G দেখাচ্ছে তো?
features of Indian
না,
monsoon.
প্রিপেড ভোল্টি দেখাচ্ছে, মানে না ওটা ডিটেলসে গেলে পরে। অন্যান্য সিম গুলো যেমন ট্রু 5G দেখাচ্ছে, এটাতে ইয়ে দেখাচ্ছে কি, এটা কি সিম কি চেঞ্জ করতে হবে নাকি?
Then distribution of rainfall.
কিন্তু না, আমার তো আগের সিম যেগুলো আছে ওগুলো তো লাগাইছিলাম, কিন্তু ওগুলো তো
By the way, guys,
দেখাচ্ছে 5G।
do we have an idea or a
হ্যাঁ,
clue where we have Mascarene Islands? Yesterday we talked about the Mascarene Islands. Do
কিন্তু
we have a clue where do we
সেটাই তো
have
আমি জানি।
Mascarene Islands?
হুম,
It is in
না করছি আমি 2-3 দিন ধরে করছি, আজকে তো না, সে তো
southwestern
10
portion
তারিখে
of
অ্যাক্টিভেট হয়েছে।
Indian Ocean. Peru, no. Southwestern portion of Indian Ocean. Besides
5G
Africa.
মোবাইল হ্যাঁ আছে,
Good. Western
লাগাইছি,
disturbances.
কিন্তু তাও দেখাচ্ছে না। না, মনে হয় সিমটা চেঞ্জ করতে হবে।
Now, ideally, India's climate is part of Indian geography.
হ্যাঁ,
But then, because we are talking about the portion of
হ্যাঁ,
climatology, and I have
রিপ্লেসমেন্ট
understood
ফ্রিতে
the
নাকি?
amount of retention capacity and the revision capacity that many of us
হ্যাঁ,
have. So it is always advisable to refer to this while we are dealing with climatology, so that once this portion is clear, this area of Indian geography,
কিন্তু না,
in general,
রিপ্লেসমেন্টে
which
কই
is a very
টাকা নেয়
important
তো।
portion of Indian geography, that also will be taken up along with that. Now,
তাহলে
for
এটা
the
কি হবে?
mains, you will also find questions
হুম,
ranging from the portion
হ্যাঁ,
of western disturbances,
যে সিম তো হারাই গেলে পরে আমার কাছে সিম কি করে থাকবে?
what they are, the portion of factors influencing
আমাদের ইয়েতে কি বলে, ওর নাম কি, পোস্ট অফিস মোড়ে যে ইয়েটা জিও স্টোর,
and you get a kind of a supplementary question along with that
স্টেট বাস স্ট্যান্ডের
that also
অপোজিট স্টোরে।
describe about or discuss about
হ্যাঁ,
the
হ্যাঁ,
variation in Indian rainfall or the distribution of Indian rainfall.
হুম,
So
হুম।
that kind of a variation in question is
এমনি
something
চেনা
that
আছে
you
কারোর?
should experience. Okay. Now, before entering into the area
ঠিক আছে।
where we study about the factors influencing Indian climate, here, first of all, a basic about monsoons. So when we say monsoon, as we already have talked about it, so monsoon refers to the seasonal reversal of wind. Seasonal reversal of wind. When we have the seasonal reversal, so if a wind direction in a region is like this, if let's suppose it gets reverted into this direction after a particular or during a particular time of the year, that is the reversal of wind direction. So that condition is what is referred to as monsoons. Now, here, when we talk about these monsoons, it is something which we Indians have known that we have a season of rainfall, and we have known this for a long period of time. But it was the Arab travelers who basically came upon this and chanced upon this many hundreds of years back. And that is when they understood that while coming to India, you have a particular season from the month of June to August and almost up till September, where the winds, they are having a direction towards the Indian coastline, towards the western coast of India. And then that is the time that they would utilize to come laden with their ships or carry their ships towards India. And then they would know that there is a seasonal reversal, and in the month of after that, that is the month of November, December, etc., the wind direction would be exactly the opposite. And that is the time they would utilize to move away from India and carry out their trade. So that is where the term Mausim earlier was used. Mausim. So Mausim here refers to seasons. Okay. And slowly it has taken the name of monsoon. Now, you have the various aspects of monsoon. We'll take a look at that in a few moments. But before that, let us analyze the factors which influence the climatic conditions in India. Now, India is a region where you experience a variety of various different types of climatic conditions. You experience or you come across a various different types of climatic conditions across different parts of the country. Now, in our country, when you move from north to south, when you move from east to west, not only do you experience a variation from very cold conditions in the northern part to very warm conditions in the southern part, very heavy rainfall in the eastern part to deserts in the western part. Think about a climatic condition, imagine about a climatic condition it is to be found in India. The diversity of Indian subcontinent is something that we will be discussing at a later stage when we initiate the full-fledged discussion about Indian geography, that why it is referred to as a subcontinent and why it is a subcontinent in the truest of the terms. But that is something very unique to India. And that is the beauty of this particular landscape. So what are the factors which influence the conditions? So first of all, the latitudinal extent. Now, when we talk about the latitudinal extent, so here, when we talk about it, so here you have to understand that, and I am sure all of us know, India lies entirely in the northern hemisphere, and India is completely above the region of equator. Tropic of Cancer passes through the central part of the country. It almost appears to divide the country into two parts, almost. So the region to the north of the Tropic of Cancer will experience a kind of a subtropical climatic condition, whereas the region to the south will experience tropical, and eventually, as you keep on moving to the southern part of the country, there is a variation in the climatic conditions. So the climatic variations between the north and the southern part of the country is primarily because of the latitudinal extent that we have. And it is here, had India lied to the south, had India been on the region of or in the area of equator, our climatic conditions would have been very different. Had we been situated completely to the north of Tropic of Cancer, our conditions, our climatic conditions would have been very, very different. So our climatic conditions, they are influenced by the latitudinal extent. Then the Himalayan mountains. Now, Himalayas, they do influence and impact our lives in many different ways, more than many ways. Traditionally, if you talk about it, not only are these the sources of these giant rivers which originate from the Himalayas, which provide endless supply of water, but also when we talk about the Himalayan mountain region and the Himalayan region and landscape in general, you have to understand that they also provide a kind of a natural defense, a natural frontier in the north. They protect us from the cold winds coming from the region of the north. And that is where they provide a kind of a shield for us. Now, we have seen in the case of blizzard in United States that how when you have the cold local winds in the form of blizzard, they can impact the almost the entirety of the United States, because in the region of United States and North America, you don't have an east to west mountain system. So they do protect us from the cold winds from the north. Also, these act as a kind of an orographic barrier, and that orographic barrier provides rainfall. So the moist winds coming from the region of Arabian Sea and Bay of Bengal, they hit the Himalayas, they cause rainfall. even for the
Hey!
natural defense
নকশা করিস না।
against enemies, Himalayas have always provided a kind of a natural frontier, natural boundary for us.
টেবিলের উপর নাই, টেবিলের
If you
মধ্যে
take
দেখে অন্ত।
the case, be it as early as the Huns or the Mongols, they have never been able to cross the Himalayas. So the role of Himalayas in our lives has been truly enriching and much greater. But when we talk about the climate, it is very substantial. So they act as an effective climate divide. They protect the subcontinent from the cold northern winds. They act as a barrier which stops the moist winds coming from the nearby water bodies and cause significant orographic.
টস দিয়ে কোথায় দেখবো এখন? হ্যাঁ, এখানে এখন ফেলবো।
See it. And orographic.
একটা জায়গায় যাবো, এখন যাওয়া যাবে না।
Barrier and cause significant.
চাবি কোথায় রাখছিস দাদা? দিয়ে দাও, বকা দেবো না, দিয়ে দাও।
Rainfall. So imagine if the Himalayas would not have been there, then not only would the northern part of India would be very cold, further cold, it would have been exposed to very cold winds coming from the higher latitudes, but also there would be nothing stopping these moist winds and there will be lesser rainfall. Now after today's session, I want you to open up the atlas and take a look to the west of India at the similar latitude. You will find that at the similar latitude, you will find the presence of desert areas, be it in the region of Pakistan, be it in the region of, even when you talk about Iran, be it in the region of West Asia, be it in the region of Africa. At the similar latitudes, you have the creation of the high pressure and you have the creation of a desert. But it is because of the Himalayas that the northern part of India is not a desert. Okay, so Himalayas have a significant role to play. Then we have the relief features. Relief features in the sense, here they talk about the physical barriers. Physical barriers which have been imposed, which have been created by the plateaus, the hill systems that we have. Now, the relief features that we experience, they create what kind of rainfall? Orographic rainfall. What is orographic rainfall? So whenever you have any obstruction in the form of a mountain or let's suppose even a plateau, they will push the winds upwards. They will create the vertical rise of the winds, due to which the winds get very cold, they start to condense, they form very dense clouds and they will cause rainfall.
কই চাবি কই?
Meanwhile,
রাখছিস কোথায়?
on the other side of the mountain, will this region receive rainfall or will this region be dry? What do you think? It will be dry. This is what is the leeward side of the mountain and the rain shadow zone. Perfect. Very good. Leeward side and the rain shadow zone. Okay, so that will be very dry. Okay, overall, if you take a look at the stretch of the various different physical divides and the various different physical features that we have. So if you talk about the region of the Himalayas, for example, let's suppose if you consider the ranges of the Himalayas, they form a barrier, they form a consistent system here. You have the ranges of the Himalayas here in this area. So there is a barrier here as well. You have the ranges here as well. Now, what they do is, they in a way stop the moist winds. They act as a barrier for the moisture bearing winds. Now, that is the reason why when the moist winds from the nearby Arabian Sea, when they hit the region of the Western Ghats, now this portion of the Western Ghats, they receive very heavy amount of rainfall. they receive very heavy amount of rainfall. Now here you will find that you have the prolonged stretch of Vindhyas and Satpuras. They provide a kind of a passage for the wind. The wind can reach to the central portion of India, cause significant amount of rainfall here. Otherwise, this area is drier. This is the dry region in general. Why? Because it is on the leeward side, the rain shadow zone. This area is also dry, the Thar Desert. Why? Because of the alignment of the Aravallis, the orientation of the Aravallis. Because the shape and the orientation of the Aravallis is such that the moist winds coming from the region of Arabian Sea, they move almost parallel to the Aravallis. There is nothing stopping them at all. At max, there will be some rainfall observed in the southern part of Rajasthan and portions of Gujarat, the area around Mount Abu, for example. Then, even when we talk about the moist winds coming from the region of, let's say, Bay of Bengal, they will end up hitting the region of the Aravallis. So, the region of Thar Desert is in the leeward side. So, that is why the area of eastern and southern Rajasthan will receive rainfall, but western Rajasthan continues to be very, very dry. Now, if you observe the mountain stretches and the hilly stretches in the northeast, now here you observe that the hills make up a kind of a funnel shape. So funnel shape, basically what it actually translates on the ground is that if you have the moist winds coming from this area, when they hit the Himalayas, some portion will come here, some portion will cause rainfall here. The portion which enters the northeast, whatever amount of moisture that it has, whatever amount of moisture that it carries, it will immediately be dropped here in this region. That is why the northeastern region, because the moist winds get entrapped there, that is why the northeast region also is a region of very heavy, very intense rainfall activity which is observed. So that is how the presence of these orographic features or the relief features, they will end up influencing the amount of rainfall, the rainfall distribution in general that is experienced. So, for example, the windward side of Western Ghats and Assam receive high rainfall, whereas the southern plateau remains dry. So, it is the aspect of rain shadow zone and the leeward side as well. Now, India is a landmass which is surrounded by water bodies from three sides. That is why the entire stretch here, that is referred to as a peninsula. A peninsula is a landmass which is surrounded by water body from three sides. Now, being surrounded by water bodies from three sides means what? It basically means that you have multiple factors here. Long coastline. Now, coastal areas experience moderate amount of temperature throughout the year. Then also during the summer months, we know that there's a differential heating of land and water every time. So during the summer months, the land gets very, very hot. Nearby water body is comparatively colder. We know that. So when you have the summer months, due to intense heating of the landmass, you have a low pressure created over the landmass, a significant low pressure. Whereas the water body, because we are surrounded by a water body will experience a comparatively cooler temperature, so a comparative high pressure will develop here. Comparatively, right? So that will fuel the movement of winds here. So that is where during the summer season, during summers, land gets extremely heated, okay, water is comparatively cooler. So you have a comparative pressure gradient which is created. Pressure gradient. So in general, during these months of the summer season, what will be the direction of the wind movement? Wind is onshore. Onshore winds are rich in moisture. And winds which are rich in moisture cause rainfall. Okay, they end up causing significant amount of rainfall in the process. So that is what you experience in this situation, that they end up creating and causing sufficient amount of rainfall in the process. So early explanation of monsoon, which was provided few centuries back when we did not have enough information, so you had the basic explanation which was provided for the monsoon, that see, the land gets heated, that land experiences low pressure, and then the nearby water bodies get comparatively cooler. So that is why winds will come from sea to the land, and that wind will be rich and moisture laden, and hence it will cause rainfall. It was the simplest and the earliest form of explanation for the monsoon rainfall. It was later on understood that these wind patterns, they are impacted by many things. Temperature and events in the Pacific can end up influencing the impact over the Indian region. The heating of the Tibetan highlands can end up impacting the temperature over and the amount of rainfall received in India. So that is where slowly and steadily we get to know more about the impact of the monsoons and the cause of the monsoons. Then you have a variation in temperature experienced different parts of the country, and that is primarily dominated by the altitude, or differentiated and determined by the altitude. So when we talk about the altitudinal variation, so here different places have different amount of height, isn't it? The height is different. So when the height is different, so that means with altitude, the temperature tends to reduce significantly, isn't it? So you will have the places which are situated at greater altitude, they will always experience a kind of a lower temperature or lower temperature in general. Whereas the places closer to the sea level in the plains, they will experience a higher temperature. So for example, take the case of Agra and Darjeeling. Now, even though both of them are situated at a similar latitude, you'll find that because the elevation of Darjeeling is higher, Agra is closer to the sea level. So that is why the temperature in Darjeeling is much lower as compared to what you experience in Agra. So that is where the altitudinal variation also creates a difference in the temperature which is experienced. Now, after this, we come to the portion of the factors influencing the Indian monsoon. So, Indian monsoon is impacted by many different factors overall. So, first is the differential heating and cooling of the land. That is the rate at which the land gets heated and the water gets heated. So, that is different. So, that is basically going to create a pressure difference. So, this creates a pressure difference. A pressure difference. Okay. That will induce a kind of a movement. Then the shift of the ITCZ. The ITCZ also ends up shifting with the variation in the seasons. We do know that there is a shift of the pressure belts, and ITCZ being dominated or determined by the presence of the low pressure, the thermal low pressure. So the region which gets very heated up, the ITCZ also shifts during the summer months. As if you talk about the present conditions, now the ITCZ has been present for the past couple of months significantly in the northern portion of India. ITCZ can extend into the region of the northern plains of India as during the month of April and May, the temperature keeps on rising, the ITCZ shifts north as well. Then here we have the subtropical westerly jet stream. It has got a significant influence to play and a significant role to play. The subtropical westerly jet stream is something that we studied just now, right? Heating of Tibetan Plateau and the creation and generation of the tropical easterly jet stream. Okay, so basically, when we talk about the tropical easterly jet stream, that is also created because of the heating of the Tibetan Plateau that strengthens the Indian monsoon. It can provide excessive rainfall during certain years. So that is the role which is played. We will talk about all of this. I have provided in the PPT and the slide the written text as well, so that you don't need to create copious notes out of it. So as of now, I just want you to pay maximum amount of attention that you can to the entire aspect. Then you have the mascarene high. This is basically the high pressure created around Mascarene Islands. These are the drivers of the monsoon winds, right? So these are the areas where, or this is the region from where the monsoon winds, they are driven off or they originate. Then you have the impact of Enso cycles, that is El Nino, La Nina circulation, and also the impact of IOD. So first of all, let us understand these factors in detail, and then we will be able to get at the entire mechanism driving the Indian monsoon. So first of all, we come to the portion of heating of land and water. So let's have the equator first, a rough equator. Now here, during the summer months, that is in the region, in the months of later part of March itself, in the portion of May, and also in the months of April, you will observe that the land gets significantly heated up. So when the land gets heated up, you have the creation of low pressure. This gets heated up at a much greater rate. When we talk about land and water, always land will get heated at a much exaggerated rate. So that is where it gets heated quite disproportionately. So when it gets heated up, that creates a thermal low pressure. Nearby body is comparatively cooler. So here you have a comparative high pressure. Comparative. Always remember the term comparative. So that is where you will have the winds which originate from the water body or generally driven from the water body to the land areas, the onshore winds, these will bring moisture. So during the summer season, land becomes extraordinarily hot. You would have experienced that in majority of the parts of the northern part of the country, we start experiencing the temperature close to around maybe 45 to even sometimes even 50 degrees Celsius. So the temperature experienced is extraordinarily high. So the land becomes extraordinarily hot. The nearby water bodies are cooler in comparison. As a consequence of this, the cooler moisture-laden winds from these water bodies, they hit the landmass, causing sufficient amount of rainfall. Okay, so that is when they will hit the landmass and they will cause high amount of rainfall because the winds are laden with high amount of moisture. Then we have the shift of the ITCZ. ITCZ is what? ITCZ is the thermal low pressure zone. Thermal low pressure. Now recall the tricellular model that you had seen. Now this ITCZ it shifts north and south in between the various seasons. It will shift to the area where you have significant amount of heating which is created. Now, during the summer months, when the temperature in the entirety of the area, right from the Sahara Desert to the Arabian Peninsula, to even when you talk about, let's say, the Indian subcontinent, here also, the temperatures oftentimes, they exceed around 45, 50 and 45, 48 degrees Celsius. Easily they are above 40 degrees Celsius. So the low pressure, the thermal low pressure shifts over to India. Now, that is the general movement. So the ITCZ shifts north during the summer, and again during the winter, when it is the summer in the southern hemisphere, the ITCZ then has its movement or its march to the south. So again during the winter, observe it comes slightly to the south. But during the summer, that is when it ends up moving over the northern part of the country. And this is the driver or the attractor of the winds. How? Let us understand that. I will show you the satellite image of the wind pattern which is experienced as well, so that you get a better clarity about that. So here, let's suppose you talk about the equator here. Now, during the summer season, these areas, they get extraordinarily heated up. All these areas, Thar Desert, Northern Plains, they get very, very heated up. Now, the ITCZ, over a period of time, it reaches there. But that reaching or that movement, it won't be a sudden movement. That is a slow movement. So you will observe that slowly it moves. So how does the movement happen? So initially the ITCZ from the month of March, in the month of March, ITCZ will be somewhere here. Then in the month of April, ITCZ will be somewhere here. In the month of later part of April and May, ITCZ will be here. Then in the month of June, July, and some parts of August, ITCZ will end up reaching here in the month of June, July. Okay. Now, once the ITCZ, let's suppose, reaches this particular portion. Now, as per the tricellular model of circulation, ITCZ is the attractor of winds. Isn't it? As per the tricellular model of circulation, you have the ITCZ, and from there, from both the subtropical high pressure belt, winds, they come in, they are attracted towards the ITCZ, they rise up, they form clouds, they will cause rainfall. Right? This is something that we have studied significantly and we are comfortable with. Now, when the ITCZ is shifted here, now obviously this northern subtropical high pressure belt would also have shifted somewhere here in the north. So those winds won't be able to reach the ITCZ because of obstruction provided by the Himalayas. But nonetheless, the ITCZ will continue to attract winds from the southern part of the subtropical high pressure belt. The southern part of subtropical high pressure belt is created around the region of the Mascarene Islands. Remember, in that module of atmospheric circulation, we had seen that you have the pressure zones, pressure cells which are created, the high pressure and low pressure cells. So this is where you have the high pressure, and that is high pressure near Mascarene Islands. The high pressure which is created near Mascarene Islands. Now here, when you have the movement of the wind from this region, earlier the wind will be deviating to the left. Now the winds have only one destination in this case. The winds in this case have a destination that is what? That is basically the ITCZ, isn't it? So the winds have a movement towards ITCZ. That is what they are trying to reach at. But the winds will be deviated to the left owing to the Coriolis force. Okay. This STHP here stands for the subtropical high pressure. Subtropical high pressure. So here, the winds, after they cross the equator, what do you think will happen? Around the equator anyways, you won't observe any kind of significant Coriolis effect or any kind of bending. But as soon as they cross the equator, these winds, they will bend to the right due to the Coriolis force. They will start bending to the right and they will start approaching here. The winds approach here. The winds will be crossing the region even into the area of the Bay of Bengal. They will hit the Arakan Yoma, Pegu Yoma, Tanasarim mountain ranges, and then they will be diverted here. Isn't it? Now their destination is what? ITCZ. Now what is the direction of winds in general here? What is the direction of winds? We have discussed that the winds are named based upon their direction. The winds, can we say they are coming from southwest direction? Isn't it? We can say that they are coming from the southwest direction. So that is why these are the winds which are referred to as the southwest monsoonal winds. And this has happened when the ITCZ is advancing over the Indian subcontinent. So slowly and steadily these winds will be advancing over the portion of India. So that is why this is referred to as the southwest monsoon. Okay, so these are also what are referred to as advancing monsoons. Okay, so the winds will bend owing to the Coriolis force. That is why they will start bending to the right. Their ultimate destination is the ITCZ. That is their ultimate destination. And this ITCZ, by the way, first of all, I'll show you the satellite image here. Observe this satellite image for the wind direction. Observe the satellite image here. Observe how the winds, they are originating from the region of southern hemisphere. They are moving here. They are crossing the equator. They are bending to the right. Right. And observe they are in which direction? They are in the direction of southwest to northeast. So that is what you will have as the wind movement in general. Okay, so that is why it is southwest monsoon. Okay, so that is the case of the southwest monsoon. Now from here, I want to drive another concept from this particular portion. So the concept of advancing monsoon. So it is not as if suddenly the ITCZ has reached in the northern part. In the month of April, late part of April, ITCZ will lie somewhere here. Now ITCZ, when it lies over this region, what will be the wind? The wind till that point of time will have a motion like this. Right? Now this is the low pressure. This is the ITCZ, this is the low pressure. So winds are attracted towards this low pressure. Now, let us understand a particular concept here. So when we say that the ITCZ is present in this position, can we also say, or can we also deduce that in these areas around the region of Bay of Bengal, around the region of Arabian Sea, can we say that in these areas there will be a pre-existing low pressure zone which will be created? Can we come at that conclusion? Yes? Maybe. Okay. Maybe also works for me. So we can say ITCZ is the region of low pressure. So that is where you will have a pre-existing low pressure. And pre-existing low pressure belt over the water body during the summer months or during any season, that can create a condition for which atmospheric phenomena? What do you think? When you have a low pressure over water body, which atmospheric phenomena? Good. A cyclone. So that is why in the part of late April, when the heating has already begun in the northern hemisphere, that is a season of cyclone. Either in Arabian Sea or in Bay of Bengal. Okay? Then, in the month of May again, when we talk about the month of May, the ITCZ would move further. Let's suppose we consider that in the month of April. Let's suppose we consider that in the month of April, this is the extent of ITCZ. In the month of May, this is the extent of ITCZ. Right? So again, when we talk about the month of May, this is where, again, what will happen? A tropical cyclone will develop. Isn't it? If you have sufficient heating of the water body, that low pressure is sufficient and significant to create that cyclone. Isn't it? Now, after that, furthermore, in the month of June also sometimes, you will observe that ITCZ, it gets distorted here. It remains like this. So there also, early June, sometimes, very rarely. Okay, so early June, that is very rare phenomena, by the way. This year we did experience this. Biparjoy was created in the early months or early time or the early days of June, if you recall. Now, once the ITCZ has reached here in the month of July, August, it stays there. September is when it starts withdrawing. So in the month of July and September, July and August up till September, when ITCZ is over land area, will you experience that low pressure development of the water body? No. That is why in the month of July, August, late part of June itself, late part of June, July, August, there you don't expect or you don't experience a tropical cyclone to get created. Okay, so that is why you don't have the cyclonic seasons in these months. Now, from the month of September onwards, as the September is when you have equinoxes. After September, you have the southward movement of the sun, the position of the sun. So, in the month of October, sun will be slightly in the southward position. So, that is when, from the month of September onwards, the ITCZ begins its retreat. So, October will again, when it will be retreating. Then, when we talk about, let's say, the month of November, as the ITCZ is withdrawing, so let's suppose in the month of June or month of July, this is the position. So all the winds will be directed towards this particular ITCZ. Now, from the month of September onwards, as this starts to retreat, in the month of late October, November. November is when the ITCZ will come back here. Late November is where it will be here. December is when the ITCZ will be here. So that again will create the condition of low pressure. So that is where you will also experience this in the month of November and December. Is that understood? That which are the seasons of cyclone experienced in India. Now, many of you had a question earlier about the movement of the cyclones. Why is it that the cyclones are moving in the northern part? Why is it that they move in northern direction? So here, again, the answer lies to the position of the ITCZ. Let's suppose there is significant heating of the water and the land areas as well during the summer months. In certain cases, for example, when you had the cyclone Taukte, which developed over the region of Arabian Sea, the Arabian Sea waters had gone to a temperature of 32, 33 degrees Celsius. That is how hot it had gotten. So it can get very, very hot over a period of time. So here, if you observe this, let's suppose you have the ITCZ in this region. Let's suppose there is a heating which has occurred, and that heating has created a tropical cyclone in this region. Let's suppose. Now, in this region, if a tropical cyclone is created, now it will be aided by the wind motion. The movement of that cyclone will be aided by the wind motion. Wind motion is towards where? Towards the ITCZ. So generally the wind will try to carry it towards the ITCZ, but there will be the Coriolis impact on the wind as well. So the wind will have a kind of a movement like this. So which areas will it hit? It will hit the coastline of Gujarat and Maharashtra. That is why you will very rarely observe that a cyclone has hit the western coast of Karnataka. Never. Generally, it will hit the coastline of Maharashtra. The Arabian Sea cyclones will hit the coastline of Maharashtra and Gujarat. Now, imagine similarly, if you have a cyclonic disturbance which develops here. Right? Now, that cyclonic disturbance will end up moving towards the ITCZ. It will curve as well. So that is where it will hit the region of Odisha, Bengal, and the region of Bangladesh. So cyclones which generally occur in the months of April and May in Bay of Bengal, they will end up hitting the northern portion of the coastline, that is Odisha, West Bengal, and portions of Bangladesh. Cyclones which occur when the ITCZ is here in the month of December, they will have an impact over the region of Tamil Nadu, Andhra coastline, and overall, because the impact is created, they will also influence some parts of Kerala coastline. Okay, so that is why you have the movement of the cyclones. Okay, why is it that the ITCZ line is curved? Because the land is much more hotter. The isotherm. Observe the isotherm map, you will understand. So the ITCZ is a zone indicating lowest pressure in the tropical region. This is the thermal low pressure. Thermal low pressure. Okay. Now it is in this zone that winds from both the tropics, they end up converging. ITCZ moves to the north and the south with the apparent movement of the sun, with the heating of the land, cooling of the land. Now during the monsoon months, which follow a prolonged summer season, always monsoons will follow a prolonged summer season. If the summer has not been very hot, the monsoon and its impact will also be slightly weakened, because that intensity of low pressure will not be high enough. So during those months, the ITCZ passes through the northern portion of India. So this attracts winds all the way through the southern subtropical high pressure belt. Now the winds which are coming, they would have traveled thousands of kilometers over the water body. They would have traveled thousands of kilometers over the water body. So they would be very, very significantly laden with moisture. So that is when you have very moisture laden winds. Moisture laden winds. And this creates rainfall. And that is why southwest monsoon brings copious amount of rainfall. By the way, if I ask you which are these winds? When we talk about the classification of these winds, what can these winds be? Good. Very good. These are your trade winds. The trade winds which have simply crossed over into the portion of the northern hemisphere. Okay, so these are basically the trade winds that you have. Okay, now then after that, why did they bend leftwards in the region of Bay of Bengal? Because they are attracted towards the ITCZ. The winds, they will only know high pressure and low pressure. So that is why they are attracted towards the ITCZ. All of them, they are attracted towards the ITCZ. Okay. Now, then we come to why not in October? Because in October, you don't have the low pressure system over the water body, and October is cooler. So that is why no cyclone in October. Why not in August? Someone will ask. So before that itself, because in August, you don't have the low pressure system over the water body. August is also comparatively cooler than the summer months. That is why no cyclone in the month of August as well. Whenever you have the movement or the presence of ITCZ, that is when the ITCZ over the water body, that creates a conducive condition for the low pressure that will end up creating a kind of a cyclonic circulation. Okay. Now, then comes the role of the subtropical westerly jet stream. The subtropical westerly jet stream. So that is something which also ends up traveling and shifting with the pressure belts. It shifts with the pressure belts. With the pressure belts. Right? So that means during the summer months, shifts north. In winter months, shifts south. Okay. Now, as we had seen earlier, if I can take you back a few slides here, as we had seen earlier in this case, that the pressure, the subtropical westerly jet stream, it gets bifurcated into the northern and southern branch. Why? Because of the obstruction in the form of Himalayas. So let's suppose you consider the Himalayan mountain range. Let's suppose you consider the Himalayan mountain range. Now, if the jet streams are moving at this level, they cannot simply crisscross or climb over the region of the mountains, can they? You cannot expect them to climb over the mountains. So that is why they get divided into a distinct southern branch and a distinct northern branch. Now, this is your jet. Immediately, it will start supplying more winds here. Then when it moves to the north, the entire jet stream, when it moves to the north, the northern branch will get stronger, southern branch gets weaker. So let's apply that same logic. So here we have the presence, first of all, of equator. Let us draw the equator here. So during the winter months, in general, when we talk about the subtropical westerly jet stream, so during the winter months, they end up moving to the south. Now you have a northern branch which ends up meeting here again, and you have a very distinct southern branch. Now during the winter, the southern branch of the jet stream will be very, very strong, because the entire jet stream formation, the entirety of this movement will keep on supplying to the southern branch. That is where they are situated. This is your winter. Now, as the summer comes in, the heating of the land begins. The ITCZ begins to move to the north. Now, as the ITCZ will move to the north, the entirety of the Hadley cell in itself, that is the subtropical high pressure belt, that will also move to the north, isn't it? We have the shift to the pressure belts. So during the winter months, you have the shifting of the pressure belts to the south. During the summer months, you have shifting of the pressure belts to the north. This basic is clear. Anyone who is not clear in the shifting of the pressure belts? Okay. Clear? Right. Why it will shift to the south? Harmeet, change the topic. We are studying the same thing for 4 hours. So what do you want to talk about, Harmeet? Can we talk about the no confidence motion in Lok Sabha? Is that something that would interest you, my dear friend? I hope you are able to understand that this is the class of geography that you are attending. Right? Do you want to talk about the no confidence motion? Do you want to talk about the privilege motion which is passing? No? Okay. So let's come back to the topic and let's be serious here. So when we talk about the shifting of the jet streams, why is it that the jet streams, they shift? Jet streams shift because of the shifting of the pressure belts, right? Jet streams, they shift because of the shifting of the pressure belts. What is the main reason for occurrence of heavy floods this year in the North India in the month of July? Patience is something that is absolutely lacking. Okay, let me tell you. You had the Bay of Bengal branch of monsoon interacting with the western disturbances that created excessive amount of rainfall in the Himalayan foothills, because the ITCZ at that point of time was over the region of the Himalayan foothills, and that caused floods. Got it? Good. So now can we move ahead with the rest of the discussion? So when we talk about the shifting of the pressure belt, the shifting of the pressure belts basically happens with the shift of the seasons, with the change of the seasons that we have. So when we have the change of the seasons, so basically we have the entire tricellular model which gets shifted. So this jet stream, the subtropical westerly jet stream, that gets bifurcated into two different parts because of the obstruction provided by the Himalayan mountain ranges. And because of that physical barrier, you have the distinct northern and the southern branch. Now, when we have the winter season, as all the pressure belts are shifting to the south, so that is why this this jet stream, which is above the subtropical pressure belt, they will also be shifting to the south. So as they shift to the south, the southern branch of that westerly jet stream, that will be significantly strengthened. So that is why during the winter months, the southern branch of this jet stream gets stronger. I hope that is clear. Now, when we come to the summer months, summer is when the heating begins. the heating is significant. Now, when the heating happens, that means all the pressure belts, they will shift to the north. All the pressure belts, if the ITCZ will also shift to the north, so imagine what can happen to all the different pressure zones. So all the various different pressure zones, they will be shifting to the north. So with the shift of the pressure zones, the jet stream that you have, this jet stream will also start shifting to the north. So this jet stream will start shifting to the north here. Now, as this jet stream has shifted to the north, can we say in the summer months it is the northern branch which will get powerful, and it is the southern branch which over a period of time starts to weaken during the summer season, because the jet stream that has shifted to the north. We can say that. So during summer, the pressure belts shifts north. Due to which the jets also shifts north. As the jet stream also shifts north, so then what happens? The southern branch gets weaker. And weaker till it disappears or simply vanishes. That is when the southern branch will keep on getting weaker and weaker with every passing day, till one final day it will finally end up vanishing. Now, the time till which you have a distinct southern branch, till that particular period of time, it will not allow the occurrence of rainfall. We have discussed about the reason earlier, that why the jet streams, they don't allow the occurrence of rainfall, they don't allow the mixing of the wind. So that is where, till the southern branch is there, they won't allow any occurrence of rainfall. So jet streams which tend to develop over the region of the subtropical high pressure belt, during these winter months, they lie over the northern part of the Indian subcontinent, having a distinct northern to the north of Himalayas and to the south of Himalayas branch. With the onset of summer season, as the ITCZ shifts north, the southern branch of the jet stream, that starts weakening. As long as the southern branch of jet stream is there, there won't be an occurrence of rainfall. You can have one or odd here and there rainfall events, isolated rainfall events which can happen, but there will never be a prolonged occurrence of rainfall. The moment the jet stream disappears, that is when all the winds which had accumulated, the moist winds which had accumulated up till here, all these winds will suddenly have a rush towards the Indian subcontinent. And that is when they will start causing copious amount of rainfall. And that is what we refer to as the onset of monsoon. So the onset of monsoon will only happen when the southern branch disappears. That is why, despite the factors being the heating of land and water, the movement of the sun, etc., that being more or less consistent, you will observe that the date of onset of monsoon is something which is always a surprise till the final week. It is not declared up till the final week that the monsoon can come here. The monsoon can basically come, the onset of the monsoon can happen in last May or the first week of June. Generally, the onset happens in the first week of June. So the meteorologists, they also don't know when is it exactly that the southern branch will disappear. So that is why there is a kind of an unpredictability associated with the onset of monsoon. So that is when, as long as the southern branch of jet stream exists, no occurrence of monsoonal rains. As it vanishes, air, moist air, rushes towards the Indian subcontinent. That creates onset of monsoon. Onset of monsoon is declared when you have monsoonal rainfalls experienced over the region of the Kerala coastline. Okay. Now here you might have a question that jet stream is present over central part of India. Why is it that the winds, they are not causing the rainfall in the Kerala coastline? So follow the same logic that we have talked about earlier, that the logic or the example of a traffic jam, where we have talked about the fact that, let's suppose, if you have a jet stream here, and that creates a jam of the air in, so air would be present but there would be significant movement. The moment it disappears, that is like clearing of the traffic jam. That is where sudden rush of the winds will happen. Here also winds will suddenly start to rise. Wherever the winds get an opportunity, they will receive a fresh bout of energy. That is when the winds will hit the Kerala coastline with utmost amount of force, intensity, and causes the onset of rainfall. Okay, so that is basically the aspect. So why the southern branch disappears? Because with the shifting of the pressure belts, the entirety of the subtropical westerly jet stream, it shifts to the north, so the southern branch disappears. Then we have the impact created by the heating of the Tibetan plateau. So the Tibetan plateau has got an impact, or has got the ability to strengthen the monsoon. Okay, now it can increase the amount of rainfall received in India. That is the impact of the Tibetan plateau. So heating of Tibetan plateau can increase the amount of rains received in India during monsoon. So basically, they can strengthen the monsoon. It is not that the monsoon is dependent on them. Understand this and listen to this sentence carefully. It is not as if the monsoon is dependent on it. But if this happens, it can strengthen the monsoon. It can increase and augment the amount of rainfall received. So when we talk about the Tibetan highlands or the Tibetan plateau, on an average, these are the highest plateaus which are present across the entirety of the world, with an average height of close to around 5 kilometers above the sea level. These are rocky highlands and rocky plateaus that we are talking about. And it is in these rocky highlands and plateaus where sufficient amount of rocks are present, obviously, and the rate of absorption of heat for these rocks will be high. Because generally, the rocky structure that you have, they will be absorbing heat quite significantly. So they do get heated up, and they end up creating very intense low pressure. That intense low pressure gives rise to rising air column in the region of the Tibetan highlands. This rising air column in the upper atmosphere, it transitions, it moves over and strengthens the Mascarene High in the southern hemisphere and then strengthens the Indian monsoon. How? Let us understand. So these are your Tibetan highlands. I'm sure all of you would be aware of this. So basically, when we talk about the Tibetan plateau and the Tibetan highlands, here, now here, let's suppose you consider the Himalayas. Here, let's suppose you consider the Tibetan highlands with an average elevation of 5 kilometer above sea level. Okay. Now, in this area, during the summer months, you can experience a temperature of sometimes 15 degrees Celsius, sometimes 17, 18 degrees Celsius, sometimes even 20 degrees Celsius. That creates very intensified low pressure. Suppose there is a particular summer month where you experience over the region of Tibet a temperature range of 15 to, let's assume, 20 degrees Celsius. Let's assume. That will create a very, very intense low pressure. Even though 20 degrees Celsius is not observed, generally around 10 to 15 degrees Celsius is observed. But let's give the extremity of the situation. Climate change is anyways happening. So extreme low pressure would be created. Extreme thermal low pressure. Okay, now here you might have a doubt that why is it that at 20 degrees Celsius extreme thermal low pressure is created? In my locality, in my village, the temperature is 45 degrees Celsius, we survive. But here he is saying that 15, 20 degrees Celsius is very extreme thermal low pressure. That is where you have to understand that it is in comparison and it is always in terms of the lapse rate that you have to consider, the height at 5 kilometers. At a height of 5 kilometers, you don't experience 20 degrees. Example, I'll give you the case. Let's suppose somewhere, if let's say you experience a temperature of, let's assume 40 degrees Celsius. During summer months, if you have a dry lapse rate, what will be dry lapse rate, let's assume, is at the rate of 10 degrees Celsius per kilometer. So at a height of 5 kilometer, what will be the temperature here? Minus 10, perfect. So here you will be experiencing a temperature of minus 10 degrees Celsius. Whereas here you have a temperature of 15 degrees Celsius, even 10 degrees Celsius, even 20 degrees Celsius. So that is a very high amount of temperature. Now, when we have a very high amount of temperature in comparison and a very intense low pressure, so that intense low pressure will create a rising air column. Let's assume this is your equator. Let's assume this is the region of Mascarene Islands. So here, it will create a very intense low pressure. Now, in the region of intense low pressure, what do you have? Air will rise up. Air will rise up, and then the air will diverge. Right? The air will diverge. Now, the air will diverge in all different directions, owing to obviously the Coriolis force, etc. So here, if you can look at it and if you can have a view about it, so basically, imagine that the air is rising up here. Once the air reaches the upper atmosphere or the upper region of troposphere, it will be diverging in all different directions. Right. Now, one portion of these that will take a bend, that will be moving over the region of India in the upper atmosphere. These are your upper atmospheric winds or upper tropospheric winds. These are the upper tropospheric winds. So here, that wind pattern we will take as notice. So this will be basically, it will move. It will actually follow a direction. If you have to imagine, it will follow a direction somewhat like this, what is referred to as the Kolkata Hyderabad axis. So it will follow a direction. It will rise, bend, follow a direction like this in the upper atmosphere. This is the upper atmosphere wind that we are talking about. And as soon as it crosses the equator, then what will happen? It is basically much more bent in general. Then what will happen as it crosses equator? It will bend to the left. It will continue to move. It will continue to move up till the region of the subtropical high pressure zone. That is the region of Mascarene High. It is in that area of Mascarene Islands where it will sink. And that is what will be observed. So here, this is something which is going to move. It will cross the region of equator, bend to the left after that, sink in the region of the Mascarene Islands. When it does sink in the region of the Mascarene Islands, that will, in a way, reinforce or increase the high pressure at the Mascarene Islands. Increases the high pressure in Mascarene Islands. Now, if the high pressure in Mascarene Islands is strengthened, means what? It will start driving more winds. It will start pushing in more winds. All those winds, they will cross the equator. And these are the surface winds I'm talking about. They will cross the equator. More of these winds, when they cross the equator, means they will bring more moisture overall. So that is from the Mascarene Islands, more winds will be driven. They will be crossing the region of equator, coming over to India, and end up causing sufficient amount of rainfall in the process. They will cause sufficient amount of rainfall in the process. Now, this upper altitude movement of the wind, if you think about it, this upper altitude, this is your upper altitude movement, upper air movement of the wind. So this upper air movement of the wind that you see, that is basically going to move at a speed of close to around 90 to 100 kilometer per hour. And it's generally, the direction of it is considered to be east to west. That is the general direction. That is where this wind is referred to as, with a speed of 80 to 100 kilometer per hour. So that is where this is referred to as a temporary jet, that is the tropical easterly jet. That is what is referred to as the tropical easterly jet stream. So that tropical easterly jet stream comes into existence during the summer months due to the intense heating of the Tibetan highlands. Once this tropical jet stream comes into existence, it will increase the intensity of high pressure in the Mascarene Islands, and that is what will drive more moisture-laden winds, will increase the amount of rainfall. So these are your upper air tropical easterly jets. These are your surface winds. This is upper air movement that you see. This is what is tropical easterly jet. Why not northeasterly? Because as I told you that the general direction of movement is basically much more bent over, and the general direction of movement is somewhat like this. And that is why it is referred to as a kind of an easterly jet. Okay, so that is basically your tropical easterly jet. So overall, during the summer months, these rocks, they become very, very hot. They form an intense low pressure region over Tibet. Now, resultantly, the air rises and diverges from a height. The divergent air goes all the way to the southern hemisphere and sinks over the region of Mascarene High. So, this upper air movement is sometimes referred to as the tropical easterly jet. It forms an important cycle which strengthens the monsoon by increasing the strength of Mascarene High. Increases the strength of Mascarene High. So why will it only fall over the region of Mascarene High? Why not somewhere else? That is because in that region of Mascarene High and the region of Mascarene Islands, there is already a high pressure zone which is created. High pressure, that is the dynamic high pressure, the subtropical high pressure. And in the region of subtropical high pressure, you already have a sinking air. So that is where it takes a part in that sinking air column, and that is where it sinks along with the other air column as well. That is why in the region of Mascarene High. Okay? I hope, Saranya, that is understood. Okay. Now, do these winds encounter Himalayas coming from Tibet? No. So these winds, they reach the tropopause very easily because they are rising up from the region of Tibet, which is at a height of 5 kilometers. So they will reach the region of tropopause very easily. Then we come to the portion of the Mascarene High. This is simply the high pressure which is present around the region of the Mascarene Islands. So the high pressure around Mascarene Islands. High pressure around Mascarene Islands. So this is the subtropical high pressure that you have in the southern hemisphere. Now this becomes the driver of the monsoon winds. Locate Mascarene Islands in the map, even though I have located it for you, but try to look at it from the atlas as well. So this high pressure is the driver of the monsoon winds because winds originate from here. They will move towards the region of equator. That is when they will bend and hit India from southwest direction. So we can say that stronger the Mascarene High, more will be the wind movement. Weaker the Mascarene High, weaker will be the wind movement. Greater the wind movement means more rainfall. Lesser the wind movement means less rainfall. So in a way, can we say that the strength of the Mascarene high pressure will end up determining the amount of rainfall received in India during the monsoon season? So here, this is a zone of high pressure which exists around the Mascarene Islands in southern hemisphere, and hence region is referred to as Mascarene High. Now during the monsoon months, when it is winter in the southern hemisphere, this region of high pressure is the source of winds which travel across the Indian Ocean to reach ITCZ, which lies over India during the summer months. Stronger the high pressure of Mascarene Islands, more is the rainfall because more is the wind. So any factor which can influence in a way the strength of the Mascarene high pressure, that can influence the Indian monsoon. Any factor which will increase the high pressure at Mascarene Islands will cause more rainfall in India. Any factor which can weaken the strength of the Mascarene high pressure will weaken the amount of rainfall received in India. Okay, so that is what we will study when we talk about the impact of El Nino and La Nina. So El Nino and La Nina circulation, they also strengthen and weaken the Mascarene high pressure. That is why they cause greater or lesser amount of rains received in India. Okay, ITCZ, sometimes it does disturb. So when what happens is sometimes the ITCZ does lie over the region of, does come across over the region of the Tibetan highlands as well because of the heating. So in that case, the intensity of the tropical easterly jet is much stronger. Otherwise, the ITCZ doesn't have much of an impact. Okay, so that is where we'll restrict it today. Kindly do the revision of this, and then we meet again on Monday, and that is when we will continue further. Tibetan Plateau develops low pressure during which months? During the months of the summer season. So that is when you will observe, let's suppose in the previous winter, if let's suppose Tibetan highlands have received high amount of snowfall and high amount of ice cover. So during those years, the summer won't be very hot. So oftentimes the heating of the Tibetan highland is dependent upon how much cooling has happened during the past winter. Subramania, as of now, all these details you won't be able to find in a particular book. So I would suggest to you to revise the portion from the PPTs itself. Garvet, sometimes winter also brings rainfall in my region, Haryana, because of western disturbance. We will talk in the later portion of it. Okay, and again, guys, I would on the verge of being repetitive, I would urge you, please have the revision of it. You won't be required to open up the book, and you won't be required to refer to any other source of material, because more than that, more detailed aspect we are covering in the class. So please take the advantage of it, and that will give you an edge over your competition. This exam is a competition, understand that. So that edge, please don't let go of it. Okay, right? So please don't let go of that advantage. The more you revise, better you will get at it. Everything is driven by two basic aspects of temperature and pressure. If you understand those basic aspects, the 6th and the 7th module that we have covered, all of this is simple follow-up of that doubt. Okay, how winter impact Tibetan Plateau heating? So that is basically when you have during the winter months, let's suppose a lot of snowfall has occurred, very thick ice sheet has been created. Now it will take some time for that to melt. So it will melt by the late May, maybe early June. So then suddenly a lot of heating won't happen. Imagine if there is a less snowfall. So there will be immediate amount of heating created, isn't it? No, tomorrow we don't have an extra session. We'll try to take a look at it next weekend and a weekend after. Tab lecture or live class recorded lecture should be used for revision after class. As of now, as long as the classes are going, please revise with the help of the recorded sessions. After the classes are over, after the 25 modules are over, take a look at the revision from the tablet. That will be the ultimate source. Okay? How can we study to solve questions? Okay, so that is not the type of questions which have dominated. You still have many basic questions. Prelims results are not decided based upon those random questions out there. The problem arises when, as candidates, we start chasing those random questions. So don't chase those random questions. Cover the basics, and we'll talk about it later. That what is the pattern of prelims as well. Generally, in prelims, you will always find 40 to 45 basic questions, which are coming from the basic concepts. There will be 20 to 25 extremely random questions which will be there. The problem arises that we think about it that 45 we will do correct, but it is there that we basically commit mistakes and we are out of the race. Okay. Now, Mayank, sir, the two statements are looking contradictory. That is, The sinking air creates high pressure, and the air is sinking because it has become heavy because it is cool. You are saying that sinking air becomes hotter due to adiabatic compression. So see, the high pressure which is created is not always thermally driven. The high pressure can be created due to the aspect of the dynamic pressure as well. So in a region, let's suppose due to any event, even sometimes jet streams can end up creating a zone of sinking air. So wherever, let's suppose you have that zone of sinking air, it will be high pressure. But sometimes as the air starts sinking, it will get heated, it will get compressed.